The information provided in this video is for educational and entertainment purposes only. Automotive repair involves significant safety risks, including exposure to hazardous materials, specialized high-voltage systems in modern vehicles, and the use of heavy machinery. This content does not constitute professional mechanical, structural, or legal advice regarding insurance claims or vehicle safety standards. Always consult with a certified collision repair specialist or a licensed insurance adjuster before attempting any repairs or settling a claim. The creator of this video assumes no liability for any property damage, personal injury, or financial loss resulting from the use of the information contained herein. Conduct your own due diligence and follow all manufacturer-specific repair procedures. You are looking at a 3-inch dent in the rear corner of a modern pickup truck. To the untrained eye, it looks like a simple afternoon fix with a suction cup and some touch-up paint. You take it to a reputable body shop in Los Angeles or Dallas, expecting a quote for maybe $500. Instead, the estimator hands you a professional line item breakdown for $7,400. You think it is a scam. You think they are padding the bill because of your insurance provider. But the reality is far more terrifying for the American consumer. In the United States, the quarter panel is no longer just a piece of sheet metal. It has become the most expensive, most complex, and most labor-intensive component of your vehicle's entire outer shell. If you don't understand the hidden architecture behind that piece of steel, you are at a massive disadvantage the moment you get into a minor fender bender. Historical trends in the U.S. automotive market show that repair costs have outpaced inflation by nearly double in the last decade. We are entering an era where a low-speed impact in a parking lot can officially total a vehicle that is less than 5 years old. By the end of this deep dive, you will understand the precise engineering shift that turned a simple body panel into a multi-layered technological fortress. We are going to deconstruct the actual labor hours, the specialized welding requirements that most local shops cannot even perform, and the terrifying reality of the unreparable ultra-high-strength steel. This is the masterclass on why your wallet feels the sting of every mile per hour in a collision. To understand the cost, we first have to define what a quarter panel actually is in the context of modern American vehicle manufacturing. Unlike a front fender, which is a bolt-on component that can be swapped out in 30 minutes with a socket wrench, the rear quarter panel is a structural, integrated part of the vehicle's unibody frame. It starts at the rear bumper, wraps around the wheel well, extends up the C-pillar, and often runs all the way along the roofline to the A-pillar near the windshield. In many modern SUVs and sedans, this is a single continuous piece of stamped steel or aluminum that can be over 8 feet long. When that panel is damaged, you aren't just replacing a skin. You are performing surgery on the skeleton of the car. Let's look at a case study of a common 2023 mid-sized SUV. If a shopping cart hits the front fender, the shop orders a new fender, paints it, and bolts it on. Total cost, $1,200. If that same shopping cart hits the rear quarter panel with enough force to crease the metal, the entire structural integrity of that side of the vehicle is technically compromised. Because the panel is welded, not bolted, the repair process requires the technician to literally cut the car into pieces. This is where the labor hours begin to explode. In a standard U.S. collision center, the labor rate can range from $60 to over $150 per hour depending on the region and the specialization of the shop. A quarter panel replacement often carries a base labor time of 20 to 30 hours. That is before a single drop of paint has been mixed. Why does it take 30 hours? Because of the R&I process, or remove and install. To get to the backside of a quarter panel, a technician must strip the entire interior of the back of your car. This includes removing the rear seats, the side bolster airbags, the interior trim panels, the carpeting, the headliner, and often the rear glass. If your car has a panoramic sunroof, the complexity triples. One mistake during the removal of these high-tech interior components can trigger a fault code in the vehicle's computer system that requires a dealer-level reset, adding hundreds more to the bill. Now let's talk about the metal itself. In the 1990s, quarter panels were made of mild steel. You could hammer them out, use a bit of body filler, and call it a day. Today, American roads are filled with vehicles constructed from ultra-high-strength steel and boron steel. These materials are designed to be incredibly strong to protect passengers during a rollover, but they have a one-and-done molecular memory. Case studies from metallurgical labs show that once these advanced steels are deformed in a crash, they cannot be heated and pulled back into shape without losing their structural integrity. If a shop tries to fix a boron steel quarter panel using traditional methods, that panel might shatter or fold like a piece of paper in the next accident. This forces the shop to perform a full replacement, which involves sophisticated spot welding equipment that costs the shop upwards of $50,000 to purchase. Those equipment costs are passed directly to you, the consumer. Furthermore, we have to address the hidden technology. 10 years ago, a quarter panel was just metal. Today, it is a housing unit for sensors. Behind that thin layer of paint sits your blind spot monitoring system, your rear cross-traffic alert sensors, and often the ultrasonic sensors for park assist. These sensors are calibrated to talk to each other through the metal and plastic. If a repair technician uses too much body filler, even a fraction of a millimeter too thick, the radar waves cannot penetrate the repair. This renders your safety systems useless. In the American repair market, the standard procedure now includes a pre-repair scan and a post-repair calibration. A technician must hook the car up to a diagnostic computer to ensure every sensor is aligned to within a fraction of a degree. This calibration alone can add $500 to $1,000 to the invoice. The painting process is another area where costs have spiraled. We are no longer using simple single-stage paints. Most modern American vehicles utilize complex tri-coat or quad-coat finishes with pearlescent flakes and translucent midcoats. To make a new quarter panel match the rest of your car, the painter cannot just paint that one panel. They have to blend the paint into the adjacent doors and the roof rail. This means you are paying for the labor to prep and clear coat 3 or 4 different panels just to fix a single dent in one. When you add up the mechanical teardown, the structural cutting and welding of advanced alloys, the high-tech sensor calibration, and the multi-panel paint blending, you begin to see why that 3-inch dent is a financial catastrophe. The simple repair is a myth in the age of the intelligent vehicle. We are moving toward a future where the cost of repair is the primary driver of total loss valuations in the U.S. insurance industry. Understanding this shift is the only way to navigate the high-stakes world of modern car ownership without being blindsided by a 5-figure repair bill. We are just scratching the surface of the technical requirements that define the American collision industry today. In the next section, we will break down the specific differences between OEM and aftermarket panels and why choosing the wrong one could potentially make your car a rolling safety hazard. Imagine a driver named Mark in Chicago in 2026. Mark drives a popular electric truck, a vehicle that symbolizes the cutting edge of American engineering. After a minor scrape against a concrete pillar in a parking garage, Mark faces a choice that seems simple on the surface but carries massive structural and financial implications. His insurance company suggests an aftermarket quarter panel to save $3,000 on the estimate. Mark thinks a piece of stamped metal is just a piece of stamped metal. He is wrong. This is the moment where the distinction between original equipment manufacturer parts and aftermarket alternatives becomes a matter of life and death, or at the very least, a matter of total vehicle devaluation. An OEM quarter panel is engineered by the same company that built the car. In the current 2026 manufacturing landscape, this means the panel was stamped using the exact same multi-million-dollar dies as the original factory part. The metallurgy is identical. If the original vehicle used a specific grade of high-strength, low-alloy steel designed to buckle at a precise newton-meter of force during a side-impact collision, the OEM replacement part will do the exact same thing. This is critical for the timing of airbag deployment. Modern American safety systems are tuned to the millisecond. If a replacement panel is too stiff because it uses a different steel alloy, the crash sensors might delay the airbag deployment by a fraction of a second. In a high-speed collision on an American interstate, that fraction of a second is the difference between a controlled deceleration of the passenger and a fatal impact with the interior trim. Now consider the aftermarket alternative. Historically, these parts are often referred to as competitive parts. They are reverse engineered by third-party manufacturers who do not have access to the original digital blueprints or the proprietary metallurgical formulas of the vehicle manufacturer. While they may look identical to the naked eye, the microscopic reality is different. Case studies from independent crash testing facilities have shown that some aftermarket panels differ in thickness by as much as 15%. While that sounds negligible, it fundamentally changes the way the vehicle handles energy during an impact. If Mark chooses the aftermarket panel for his truck, he is essentially installing a structural component that has not been crash tested as part of the total vehicle system. In the United States, the legal and insurance ramifications of this choice are becoming a central point of contention in 2026. The fit and finish issues of non-OEM panels add another layer of hidden costs that the average consumer never sees until it is too late. Imagine the technician trying to align a panel that is 3 millimeters too short at the window track. To make it fit, the technician has to pull, stretch, or shim the part. This introduces internal stress into the metal before the car even leaves the shop. Over 2 or 3 years of driving through the temperature swings of a Midwest winter or a Texas summer, that internal stress leads to paint cracking, wind noise, and eventually water leaks. A water leak in a 2026 vehicle is not just a wet carpet. It is a direct threat to the high-voltage wiring harnesses and computerized control modules that live behind those interior panels. Historical trends show that vehicles repaired with non-CAPA certified aftermarket structural parts see a significantly higher rate of electrical ghost issues within 36 months of the repair. Beyond the physical metal, we must address the concept of the repair procedure itself. In 2026, the United States automotive industry has moved toward a strictly regulated environment regarding repair methods. For an OEM repair, the manufacturer provides a step-by-step digital manual that dictates exactly where a technician can cut and where they must weld. This is called a sectioning procedure. For many modern vehicles, you cannot just cut the quarter panel anywhere. There are specific no-cut zones because of the ultra-high-strength steel reinforcements underneath. If a technician, perhaps working for a shop that is cutting corners to meet an insurance company's low-cost mandate, cuts through a reinforced B-pillar or a roof rail to install an aftermarket panel, they have effectively compromised the rollover protection of the entire vehicle. Let's look at the financial data regarding resale value. In the American market, a vehicle with a recorded structural repair is already at a disadvantage. However, a vehicle where the repair documentation shows the use of non-OEM structural components faces a much steeper depreciation curve. Potential outcomes for sellers like Mark include a diminished value claim that could total 20 to 30% of the vehicle's remaining market value. Buyers in 2026 are more educated. They demand Carfax reports that show not just that a repair happened, but how it was performed and what parts were used. If the report shows a structural quarter panel replacement using aftermarket parts, most certified pre-owned programs will reject that vehicle entirely. You are not just paying for a repair. You are paying to maintain the equity in your second largest lifetime investment. The complexity deepens when we look at the specialized bonding agents required for these panels. We are no longer in an era where every panel is joined by a simple MIG weld. In 2026, many quarter panels on high-end American trucks and SUVs are bonded and riveted. This involves structural adhesives that are stronger than the metal itself, applied in a climate-controlled environment to ensure proper curing. The cost of these adhesives alone can reach hundreds of dollars per repair. An OEM-specified adhesive is formulated to work with the specific E-coat or primer on the OEM panel. If you use an aftermarket panel with a different primer and a generic adhesive, you risk bond failure. Imagine driving down a highway at 70 miles per hour and having your quarter panel begin to delaminate because the chemical bond failed. It sounds like science fiction, but it is a documented risk in the world of substandard collision repair. The United States has seen a surge in right-to-repair legislation, but this has created a double-edged sword. While it allows more shops to access data, it also places the burden of knowledge on the consumer. You have to be the advocate for your own safety. When the estimator tells you that the aftermarket panel is just as good, they are often looking at a spreadsheet, not a structural engineering report. We have to ask, if the part is truly identical, why does it cost 60% less? The answer usually lies in the grade of the alloy, the precision of the stamping, and the quality of the corrosion-resistant coatings. In the salty air of Florida or the salted roads of New England, an aftermarket panel without proper zinc galvanized coating will show rust bubbles within 2 years, whereas an OEM panel is designed to last the lifetime of the vehicle. As we move further into this deep dive, we have to look at the people actually doing the work. The labor crisis in the American automotive sector has led to a massive gap in specialized training. A technician who was trained in 2015 is effectively obsolete in 2026, unless they have undergone hundreds of hours of recertification for aluminum-intensive vehicles and carbon fiber integration. This leads us to a disturbing reality. Even if you have the right part, do you have the right person? The cost of that quarter panel repair isn't just the metal. It's the specialized education of the individual holding the pulse welder. But what happens when the metal is perfectly fine, yet the car is still non-functional? What happens when the physical repair is complete, but the car refuses to start or throws 100 error codes because of the digital handshake between the panel and the chassis? The intersection of physical metal and digital software is where the true nightmare begins for the modern American driver. If you think the mechanical labor was expensive, wait until we calculate the cost of the digital soul of your vehicle. In the next part, we are going to dive into the world of software locks and component matching, the invisible barriers that are making it nearly impossible for independent shops to finish a quarter panel repair without a direct, expensive lifeline to the manufacturer's main servers. We are going to find out why your car's computer might reject a perfectly good piece of metal simply because it wasn't introduced properly. To understand why the digital soul of a vehicle in 2026 has become the most expensive part of a quarter panel repair, we have to look at the invisible architecture of a modern American car. Imagine a driver named Sarah in Seattle. She has a high-end electric sedan, and a minor collision has pushed in the rear quarter panel. The metal is replaced, the paint is perfect, and the sensors are snapped back into their brackets. But when Sarah tries to engage her semi-autonomous driving mode on the i5, the car abruptly disengages and displays a critical system error. This is not a mechanical failure. It is a digital rejection. The car knows that its physical body has been altered, and it does not trust the new components until they have been digitally notarized by the manufacturer's central server. In the United States, the concept of component matching has moved from high-end electronics into the very frame of the vehicle. By 2026, many sensors embedded within or behind the quarter panel are serialized. This means each blind spot monitoring radar and each ultrasonic sensor has a unique digital fingerprint that is registered to the vehicle identification number at the factory. When a shop replaces a damaged sensor during a quarter panel repair, the vehicle's central gateway module detects a foreign serial number. Historical trends in automotive software architecture show that manufacturers are increasingly using these digital locks to ensure that only certified parts are used. If the new sensor isn't introduced through a proprietary software handshake, the entire advanced driver assistance system may go into a fail-safe mode, disabling safety features you paid thousands of dollars for. This brings us to the massive, often hidden cost of software subscriptions and remote programming. A local independent body shop in 2026 cannot simply plug in a generic scan tool and clear these codes. To finish a quarter panel repair on a modern American vehicle, the shop must often pay for a one-day or one-week subscription to the manufacturer's specific diagnostic portal. These subscriptions can cost anywhere from $50 to $300 per vehicle. But the cost doesn't stop at the subscription fee. The shop must also have a high-speed, secure internet connection and AJ2534 pass-through device to allow a remote technician, often located halfway across the country, to log into Sarah's car and perform the calibration. This is billed as a sublet service, and it is a major reason why the labor line items on a 2026 repair estimate look more like an IT bill than a mechanic's invoice. Consider a case study involving a 2025 luxury SUV. A simple quarter panel replacement required the removal of the rear glass, which contained integrated antennas for the vehicle's 5G connectivity and GPS. Once the glass was reinstalled, the car's security system flagged a potential tampering event. The vehicle's immobilizer prevented the car from shifting out of park. The repair shop had to spend 4 hours on a support line with the manufacturer to prove that the repair was legitimate and to have the security tokens reset. In the American market, labor hours for digital troubleshooting are often billed at a higher rate than structural metalwork, sometimes reaching $200 per hour. For Sarah, this added $800 to an already expensive bill, just to get the car to recognize its own windows. We also have to discuss the physical sensitivity of these digital components. The radar units used for blind spot detection are typically mounted to brackets on the inner quarter panel or the rear body crack. These sensors operate on millimetric wave frequencies. In 2026, the tolerance for the mounting angle of these sensors is often less than 1 degree. If the structural technician who welded the new quarter panel is off by even 2 millimeters in their pulls, the sensor bracket will be misaligned. The car's software might attempt to calibrate, but if it detects that the sensor is pointing too far toward the ground or too far away from the adjacent lane, it will reject the calibration entirely. This results in what the industry calls a comeback. The car has to be torn down again, the metal reshaped, and the process restarted. This is why high-end shops now use 3D laser measuring systems during the metalwork phase to ensure that every sensor mounting point is exactly where the factory blueprints dictate. These laser systems cost the shop $30,000 or more, a capital expenditure that must be recouped through higher hourly rates. Imagine if Sarah's car also featured a digital paint technology or smart glass tinting integrated into the quarter window. By 2026, Several manufacturers have introduced electrochromic glass that darkens at the touch of a button. These windows are connected to the car's body control module via a thin ribbon cable, hidden inside the quarter panel pillar. If a technician accidentally nicks this cable while using a reciprocating saw to cut out the old panel, they aren't just fixing a wire. They are often forced to replace the entire wiring harness that runs the length of the car. In modern American vehicle architecture, these harnesses are no longer modular. They are single, continuous runs of copper and fiber optics designed to reduce weight and complexity during factory assembly. Replacing a $3,000 harness because of a 1-inch cut is a potential outcome that terrifies every shop owner in the United States. Furthermore, we must look at the role of over-the-air updates. In 2026, your car is constantly talking to the cloud. If Sarah's car receives a software update while it is sitting in the body shop with its quarter panel removed and sensors disconnected, the update might fail. A failed OTA update can, in rare cases, brick certain control modules, requiring a physical replacement of the computer hardware. Shops now have to follow strict protocols, often placing the car in a dedicated service mode, or even a Faraday cage-like environment to prevent unintended updates during the structural phase of the repair. The level of care required to protect the car's digital health is now equal to the care required to protect its physical appearance. The data shows that the software and electronics portion of a collision repair has grown from roughly 7% of the total bill in 2016 to nearly 35% in 2026. This is the new reality of the American automotive landscape. You are not just paying for a craftsman to shape metal, you are paying for a data scientist to ensure that the metal can communicate with the rest of the machine. The quarter panel is the gateway for so much of this communication because it sits at the corner of the vehicle, the primary location for the sensors that keep you in your lane and stop you from backing into a pole. But there is an even more expensive factor at play, one that has nothing to do with sensors or software. It has to do with the very air around the car and the environment in which it is painted. As we move into the next section, we are going to explore the extreme costs of the modern American paint booth. We will look at why the EPA regulations of 2026 and the shift towards specialized, multi-stage finishes have turned a gallon of automotive paint into one of the most expensive liquids on the planet. You will find out why a shop might spend more money on the electricity to bake your car than your grandfather spent on his entire first vehicle. The invisible costs of the finish are about to come into focus, revealing that the shiny surface of your quarter panel is actually a multi-layered chemical masterpiece that costs a fortune to replicate. We are going to see why matching the color is actually the hardest part of the entire job. To match the color of a 2026 American-made vehicle, a painter is no longer just a guy with a spray gun. They are a chemical engineer working in a pressurized laboratory. Consider the case of Elena in Miami. She drives a premium metallic crimson sedan that uses a complex tri-coat paint system. When her rear quarter panel is damaged, the shop cannot simply look up a paint code on a sticker and spray the new part. In the United States, the environmental regulations of 2026 have pushed the industry almost entirely into waterborne paint technology. While this is better for the atmosphere, it has radically increased the complexity and cost of the application process. Waterborne paints are incredibly sensitive to humidity and temperature. In a high-humidity environment like Miami, if the paint booth's climate control system isn't perfectly calibrated, the metallic flakes in Elena's paint will not lay flat. Instead, they will stand on edge, creating a finish that looks darker from one angle and lighter from another. This is known as flop, and it is the bane of high-end collision repair. The actual liquid sitting in those spray guns has become one of the most expensive fluids on the planet. Historical trends show that the price of high-quality automotive refinish materials has risen by 40% over the last 5 years. A single pint of specialized toner or a high-solids clear coat can cost hundreds of dollars. But the material cost is only the beginning. To achieve a factory-level finish, the shop must utilize a downdraft paint booth that functions as a clean room. These booths use massive intake fans and heated exhaust systems to pull every microscopic dust particle away from the car. In 2026, the electricity and natural gas required to run a bake cycle, where the booth is heated to 140 degrees Fahrenheit to cure the paint, can cost the shop $50 to $80 per car. When you consider that a quarter panel repair often requires multiple spray sessions for the primer, the base coat, the mid coat, and the final clear coat, the utility bill for that single repair starts to rival a monthly residential mortgage payment. Imagine the physics of light that Elena's painter has to master. Modern American car colors often include ground-up glass, synthetic pearls, and xyrillic pigments. These pigments do not just sit on the surface. They interact with light in 3 dimensions. This is why the technician cannot just paint the quarter panel and stop at the edge. To fool the human eye, they must perform a process called blending. This involves spraying the new color onto the new quarter panel, and then gradually tapering that color onto the original paint of the rear door and the roof rail. By 2026, many American SUVs have a continuous roofline that runs from the tail light to the front tire. This means that to fix a dent on the rear corner, the painter may have to clear coat the entire side of the vehicle's upper structure to avoid a visible line in the paint. The labor hours for this preparation, sanding, masking, and cleaning multiple panels, can easily double the cost of the refinish portion of the estimate. Data from the American Bureau of Labor Statistics indicates that the shortage of skilled automotive painters has driven wages to record highs. A master painter in 2026 often earns more than a junior software developer. Why? Because they have to operate a spectrophotometer, a digital device that measures the wavelength of light reflecting off the car's original paint. Even if the car is only 2 years old, the sun in Florida or Arizona has already begun to shift the chemical composition of the pigments. The spectrophotometer sends this data to a computer-controlled mixing scale that dispenses paint in increments of 1/10 of a gram. If the scale is off by the weight of a single drop of blue toner, the entire batch is ruined. This precision is required because today's consumers in the United States have zero tolerance for a car that looks like it was repaired. They expect a seamless finish, and that expectation carries a massive technical price tag. Let's look at another case study involving a matte finish vehicle, a trend that has exploded in the US market by 2026. Matte paint is the ultimate nightmare for collision repair. You cannot buff out a speck of dust in matte paint because buffing creates a shiny spot. You cannot blend matte paint. If there is a tiny imperfection in the finish of a matte quarter panel, the technician has to sand the entire panel down and start over from scratch. There is no room for error. Shops often charge a 30 to 50% premium for matte or frozen finishes because of the extreme risk of a total redo. For a driver in a city like Los Angeles or New York, a quarter panel repair on a matte finish luxury vehicle can easily cross the $10,000 mark based solely on the difficulty of the paint application. Furthermore, we must account for the masking materials. In 2026, we aren't just using old newspapers and masking tape. A modern shop uses specialized plastic films that are electrostatically charged to attract overspray, high-temperature tapes that won't leave residue during the bake cycle, and foam transition tapes to create soft edges in door jambs. The consumable supplies, sandpaper, mixing cups, filters, and masking can add $300 to $500 to a quarter panel invoice. These are items that the average car owner never thinks about, but they are essential for protecting the rest of the vehicle from the highly adhesive and permanent nature of modern urethane paints. The complexity doesn't end when the paint is dry. Once the car leaves the booth, it undergoes a denib and polish phase. Even in a $60,000 paint booth, a microscopic piece of lint can land in the wet clear coat. In 2026, technicians use specialized ultraviolet lights to inspect the surface for these imperfections. They then use ultrafine sandpaper grains so small they feel like silk to level the defect, followed by a 3-stage polishing process using computerized orbital buffers. This ensures the orange peel or the texture of the paint perfectly matches the factory finish. If the new panel is too smooth, it looks fake. If it is too textured, it looks cheap. Matching the texture is just as hard as matching the color. We are seeing a potential outcome where the cost of the finish becomes the deciding factor in whether a vehicle is totaled by insurance. In the United States, if the cost to repair and paint a vehicle exceeds 75% of its value, the car is often sent to the salvage yard. Because paint, labor, and materials have stayed so high, we are seeing 2024 and 2025 model year vehicles being crushed simply because the cost of a perfect tri-coat blend is too high for the insurance company to justify. This is the hidden tragedy of modern automotive aesthetics. Your car is a work of art, but that art is incredibly fragile and expensive to restore. But even after the paint is flawless and the sensors are calibrated, there is one final terrifying hurdle that can double the cost of the entire job. It is a factor that is hidden deep beneath the shiny surface, inside the very pillars of the car's frame. It involves the way the metal is joined together, not with heat, but with chemicals and pressure. As we move into the next part, we are going to expose the world of structural riveting and liquid bonding. We will find out why a shop might need a $20,000 specialized rivet gun just to attach your quarter panel, and why using a traditional welder could actually cause your car's frame to crack under stress. The secret of the cold repair. is about to change everything you thought you knew about how cars are built. In the year 2026, the traditional image of a body shop worker wearing a welding mask and throwing sparks across a garage is becoming a relic of the past. If you walk into a high-end collision center in Charlotte or Denver today, you are more likely to see a technician using a specialized pneumatic gun that looks like it belongs in an aerospace hangar. This is the era of cold joining, and it is the single most significant reason why structural quarter panel repairs in the United States have moved from the hundreds into the thousands of dollars. To understand this, we have to look at the metallurgy of a modern American vehicle. Consider a character named David, who owns a 2025 aluminum-bodied pickup truck. When David's truck is hit in the rear, the repair is not a matter of melting metal together. It is a matter of chemical bonding and mechanical fastening that mimics the construction of a Boeing 787. The reason we cannot simply weld many modern quarter panels is due to a phenomenon called the heat-affected zone. In historical trends, vehicles were made of thick, mild steel that could handle the intense heat of a MIG welder without losing its strength. However, the ultra-high-strength steels and aluminum alloys used in 2026 are heat-treated at the factory to achieve their specific crash ratings. If a technician applies the 3,000 degrees of a welding torch to these metals, the molecular structure changes instantly. The metal becomes brittle. In a subsequent accident, instead of bending and absorbing energy to save David's life, that brittle weld point could snap like a dry twig. This has forced the American automotive industry to adopt squeeze-type resistance spot welding and, more importantly, rivet bonding. Rivet bonding is a two-stage process that is incredibly labor-intensive. First, the technician must apply a structural adhesive to the mating surfaces of the new quarter panel and the inner wheel house. This isn't hardware store glue. This is a two-part epoxy that costs upwards of $100 for a single small cartridge. The adhesive serves three purposes. It provides a continuous bond that distributes crash energy across the entire surface. It acts as a vibration dampener to keep the cabin quiet, and it creates a permanent seal against the road salt and moisture that plagues vehicles in the American Rust Belt. But the adhesive alone isn't enough. While the glue is still wet, the technician must install specialized self-piercing rivets. This is where the equipment costs explode for the shop. A self-piercing rivet gun for a 2026 vehicle is not a hand tool you can buy at a local hardware store. These are high-pressure hydraulic systems that apply over 10,000 pounds of force to drive a hardened rivet through multiple layers of metal without a pre-drilled hole. Many manufacturers, such as those producing high-end electric vehicles in the US, require specific, brand-mandated rivet stations that cost between $15,000 and $25,000. If a shop in Davidstown hasn't made that investment, they literally cannot perform a factory-certified repair. The labor hours reflect this complexity. A technician might spend 4 hours just cleaning the old adhesive off the inner structure to ensure the new bond is perfect. If even a tiny amount of old residue remains, the chemical bond will fail, and David's truck will begin to creak and groan every time he drives over a speed bump. Let's look at a case study involving the 2024 transition of a popular American SUV. The manufacturer moved from a welded steel quarter panel to a multi-material design involving an aluminum outer skin bonded to a high-strength steel inner frame. Because of the risk of galvanic corrosion, a process where two different metals touch and begin to eat each other through electrolysis, the repair procedure requires a specific isolation layer of adhesive and specialized coated rivets. If a shop uses the wrong type of rivet, the quarter panel could literally start to corrode from the inside out within 12 months. In the United States, insurance companies are now seeing claims for repairs of the repair because shops fail to follow these precise metallurgical isolation protocols. This is why a professional estimate includes line items for specialized fasteners that might cost $5 to $10 each. When a quarter panel requires 50 rivets, that is $500 in hardware alone. Now, imagine the precision required for the pull. Before the new panel is bonded and riveted, the inner structure of the vehicle must be pulled back to within 1 millimeter of its original factory position. In 2026, this is done using a frame rack equipped with a computerized 3D measuring system. The system uses targets placed at various points on the chassis and a laser scanner to build a digital twin of the car. The technician watches a screen that shows red, yellow, and green indicators. They must pull the metal until the indicators turn green. This measuring process can take 3 to 5 hours of billable labor before the first rivet is even touched. In the American market, where frame labor rates are often higher than body labor rates, this prep work can add $1,000 to the bill. There is also the factor of one-time use components. In David's 2025 truck, the quarter panel is integrated with the roof rail and the structural foam inserts. Many modern American vehicles use expandable structural foam that is injected into the pillars at the factory to increase rigidity. When you cut off a damaged quarter panel, you destroy that foam. A technician in 2026 must use specialized foam kits to replace it. These kits must be injected at a specific temperature and allowed to cure for a specific amount of time. If the foam is not replaced, the car's roof strength rating is technically voided. Case studies in automotive safety have shown that missing structural foam can lead to significantly more cabin intrusion during a rollover event. The cost of these foam kits and the labor to install them is another hidden layer of the $7,000 estimate. Furthermore, we have to consider the clean room requirements for aluminum. Aluminum dust and steel dust are a dangerous combination. If they mix and a spark occurs, they can cause a fire or explosion. More importantly, if steel dust gets onto an aluminum quarter panel before it is painted, it will cause the paint to blister and the metal to corrode. Because of this, many American shops have had to build dedicated aluminum rooms with separate tool sets and vacuum systems. The overhead to maintain these specialized environments is massive. When you pay for a quarter panel repair in 2026, you are paying for the amortization of that clean room infrastructure. The potential outcomes for a vehicle that skips these steps are grim. It isn't just about a door that doesn't close right or a gap that looks uneven. It is about the fundamental safety of the vehicle. In the US, the total loss threshold is being pushed higher and higher because manufacturers are making these parts so difficult to replace that the labor becomes the dominant cost. We are entering a period where the complexity of joining metal has surpassed the cost of the metal itself. You could buy the raw materials for a quarter panel for a few $100s, but the knowledge and equipment required to join it to the car are what drive the price into the stratosphere. But even after the frame is straight, the foam is injected, and the rivets are set, there is a final layer of protection that most people never see. It is the invisible shield that prevents your car from rotting from the inside out. In the next part, we are going to explore the world of corrosion protection and internal sealing. We will look at why a technician might spend 2 hours spraying wax into the dark corners of your car's frame, and why failing to do so could result in your vehicle failing a safety inspection in just 5 years. We are going to find out why the most important part of the repair is the part you will literally never see with your own eyes. Jordan just got his luxury SUV back from a shop after a major quarter panel replacement in Minneapolis during the harsh winter of 2026. On the outside, it looks perfect. The paint is a flawless match, and the panel gaps are factory spec. But deep inside the hollow cavities of that new quarter panel, there is a silent war beginning. If the technician skipped the invisible steps of corrosion protection, the road salt from the Minnesota highways will begin eating the vehicle from the inside out within 24 months. This is the hidden stage of a quarter panel repair that drives up the labor hours on a professional American estimate, often adding 4 to 6 hours of meticulous work that the customer never actually sees. When a vehicle is manufactured in a modern factory, the entire unibody is dipped into a massive tank of electro-deposited primer, known as the E-coat. This process uses an electric charge to pull the primer into every microscopic crevice, every weld nut, and every internal reinforcement. It is the gold standard of rust prevention. However, when a technician performs a repair in a local body shop in 2026, they are effectively breaking that factory seal. Every time they grind a weld, install a rivet, or use a tool to pull the metal, they are creating a raw, exposed edge. In the United States, historical trends in vehicle longevity show that a repair is only as good as the E-coat restoration. If a shop simply sprays paint on the outside and ignores the inside, the metal will oxidize. The first step in this invisible process is the application of weld-through primers. Before the new quarter panel is even attached, the technician must treat the mating surfaces with a zinc-rich or copper-rich primer. This material is designed to conduct electricity for the welding process, while simultaneously providing a layer of sacrificial protection for the metal. In a 2026 American repair facility, the cost of these specialized primers has risen significantly due to supply chain complexities and the requirement for zero VOC formulations. A single aerosol can of high-quality weld-through primer can cost $40 to $60. The technician must carefully mask off the areas where the primer is not needed to avoid contaminating the final paint job, adding more labor time to the clock. Once the panel is structurally joined to the car, the technician enters the cavity wax phase. Imagine the inner structure of a quarter panel like a dark, narrow cave. It is inaccessible once the outer skin is on, To protect this area, the technician uses a specialized wand, a long flexible tube with a 360-degree spray tip, to inject a petroleum-based or lanolin-based cavity wax into the internal voids. This wax never fully hardens. It remains tacky and self-healing. If a small rock chip or vibration creates a crack in the internal coating, the wax slowly flows into the gap to reseal the metal. In states like Michigan, New York, or Washington, where moisture and salt are constant threats, this step is non-negotiable. Case studies from the early 2000s showed that vehicles repaired without cavity wax often suffered from perforated rust within 5 years, leading to structural failure during secondary impacts. The data behind these materials is staggering. In 2026, a high-end American collision center might go through dozens of gallons of cavity wax and undercoating every month. The labor involved is not just the spraying, it is the preparation. The technician must refer to a manufacturer-specific diagram that shows exactly where the access holes are located. Sometimes they have to drill small holes in the door jambs or the trunk floor just to get the wand into the correct position. These holes are then sealed with factory-style rubber plugs. If a shop skips this because they are in a hurry to meet an insurance deadline, they are essentially setting a timer on the vehicle's lifespan. Furthermore, we have to talk about the seam sealers. Look at the edge of your trunk or the area where your quarter panel meets the rear floor pan. You will see a thick, bead-like material that looks like heavy-duty caulk. In 2026, this is a sophisticated two-part urethane that is designed to stay flexible while blocking out air and water. American car manufacturers now use robots to apply this sealer in specific patterns, sometimes flat, sometimes rippled, sometimes brushed. To maintain the vehicle's value and prevent leaks, the technician must replicate this factory appearance by hand. They use specialized pneumatic caulking guns and various nozzle tips to match the original texture. If the seam sealer is applied poorly, water will pool in the spare tire well, leading to mold, electrical shorts in the rear-mounted battery systems common in 2026 EVs, and eventually the structural rot of the frame. Imagine if Jordan's SUV has a sunroof. The drain tubes for that sunroof often run down through the C-pillar and exit behind the quarter panel. During a repair, these tubes must be carefully routed and secured. If a technician accidentally pins a drain tube against the metal while installing the new panel, or if they fail to seal the exit point properly, the water will back up into the headliner. In 2026, many American vehicles feature high-tech Alcantara or recycled fiber headliners that are ruined instantly by water staining. A simple mistake in the invisible sealing of a quarter panel can lead to a $2,000 headliner replacement 6 months later. There is also the matter of sound deadening. Modern American consumers demand a tomb-like quietness in their vehicle cabins. Inside the quarter panel, manufacturers often stick large pads of butyl rubber or bitumen to the metal to stop it from vibrating like a drum. These are called sound dampening sheets. When a panel is replaced, these must be ordered as separate parts and applied using a heat gun and a roller. In 2026, some luxury brands even use a spray-on liquid sound dampener that must be applied to a specific thickness. If a technician leaves these out to save time, Jordan will notice a significant increase in road noise and tire roar the moment he hits the highway. The car will feel cheap or hollow even though it looks perfect. The potential outcomes for a shop that masters this invisible stage are high customer satisfaction and long-term vehicle safety. However, for the consumer, it is a massive driver of cost. We are looking at an average of $300 to $500 just in corrosion protection materials and the labor to apply them correctly. In the United States, where the average age of a car on the road is now over 12 years, these steps are the difference between a car that lasts and a car that becomes a safety hazard before the loan is even paid off. The complexity of these hidden layers is a testament to how far automotive engineering has come, but it also highlights why the era of the $500 body shop fix is officially dead. You are paying for a chemical barrier that stands between your investment and the elements. But what happens when the repair is finished, the wax is dry, and the car is back on the road? There is one more financial blow waiting for the American driver, and it doesn't appear on the repair bill. It is the invisible loss that happens the moment you sign the paperwork. In the next part, we are going to dive into the world of diminished value and the Carfax trap. We will find out why a perfectly repaired quarter panel can still cost you $10,000 when you try to trade it in, and how the digital paper trail in 2026 has changed the game for vehicle owners across the country. We are going to see how your car's history is being tracked by algorithms that don't care how good the repair looks. In the high-stakes world of the 2026 American automotive market, the physical repair of a quarter panel is only the first half of the financial disaster. Imagine a driver named Marcus in Atlanta. Marcus has just spent 3 weeks navigating the repair process for his premium electric SUV. The shop did a masterclass job. The rivets are perfect, the paint depth matches the factory finish to the micron, and the sensors are recalibrated. Marcus feels a sense of relief as he drives off the lot. But 6 months later, when he decides to trade that vehicle in for a newer model, he is met with a cold, hard digital reality. The dealership appraises his car and offers him $12,000, less than the current market value for a clean title vehicle. This is the diminished value trap, and in 2026, it is governed by algorithms that have more power over your net worth than the mechanic who fixed your car. To understand this, we have to look at the evolution of the digital paper trail in the United States. Historical trends show that services like Carfax and AutoCheck have transitioned from being simple history reports to becoming the primary pricing engines for the entire used car industry. In 2026, these platforms are integrated directly into the dealer management systems across the country. The moment a body shop opens an estimate and orders an OEM quarter panel, a digital flag is raised. Because a quarter panel is classified as a structural component, the report doesn't just say accident reported. It often specifies structural repair or frame work. To a computer algorithm or a future buyer, those words are toxic. They signal that the factory-welded integrity of the vehicle has been compromised and restored by a third party. Let's look at a case study of a 2025 luxury sedan. Before the accident, the vehicle had a fair market value of $55,000. After a $7,000 quarter panel repair, the vehicle is physically restored to its pre-accident condition. However, the inherent diminished value, the loss in market appeal simply because the accident happened, can be staggering. In the American legal and insurance landscape of 2026, Marcus is facing a potential outcome where his car is worth only $43,000 on the open market. That is a $12,000 loss in equity that he can never recover through physical repairs. This is why a simple quarter panel repair costs so much. You aren't just paying for the labor and parts, you are effectively paying a massive hidden tax on your vehicle's future resale value. In the United States, several states allow for diminished value claims against an at-fault party's insurance. However, the process is incredibly complex. Marcus would need to hire a certified independent appraiser to perform a forensic valuation of the vehicle. This appraiser doesn't just look at the car. They analyze thousands of auction data points from 2026 to prove how much less a buyer is willing to pay for a repaired vehicle versus an original one. This appraisal alone can cost $500 to $1,000. Then comes the negotiation with the insurance company, which often uses its own internal algorithms to minimize the payout. Historical trends indicate that insurance companies rarely offer the full amount of diminished value without a significant legal push, adding more stress and potential cost to the owner. Now, imagine the Carfax trap in the era of artificial intelligence. By 2026, AI-driven trade-in platforms use high-resolution cameras at dealership intake bays to scan for paint thickness variations. Even if the repair is not on the history report yet, the AI can detect that the rear quarter panel has more clear coat than the front door. It immediately flags the vehicle as repaired. This level of transparency means there is no longer any hiding a high-quality repair. In the past, a skilled painter could hide their work from the average eye. Today, you cannot hide from the digital sensors. This transparency is good for the secondary buyer, but it is a financial nightmare for the current owner of a repaired vehicle. We also have to consider the impact of manufacturer-certified pre-owned programs. In 2026, the requirements for a vehicle to be labeled CPO in the US are stricter than ever. Many manufacturers will automatically disqualify a vehicle from their certified program if it has had a structural panel, like a quarter panel, replaced. When a car loses its ability to be sold as CPO, it loses the extended warranty and the lower interest rates that come with that status. This pushes the car into the general used car pool, where it must compete with thousands of other vehicles. This loss of CPO eligibility is a massive driver of the $12,000 hit Marcus took at the dealership. Furthermore, let's talk about the lease-end reality. A significant portion of American drivers in 2026 lease their high-end vehicles. If Marcus had leased his SUV and the quarter panel was repaired, he might think he can just turn it in at the end of the term and walk away. However, lease contracts in the United States often contain clauses regarding the quality of repairs and the use of OEM parts. If the leasing company's inspector determines that the quarter panel repair was not performed to factory standards, or if they detect a loss in the vehicle's wholesale value due to the accident, Marcus could be hit with a massive bill for excess wear and tear or a supplemental end-of-lease fee. The cost of a quarter panel repair is a gift that keeps on giving, right up until the day you hand back the keys. Case studies from the 2026 insurance market show a rising trend in total loss thresholds being manipulated by these digital reports. Sometimes an insurance company will decide to total a car, even if the repair cost is only 50% of the car's value, because they know the diminished value and the difficulty of selling a structurally repaired vehicle will make it a liability for them in the long run. For Marcus, this means his beloved car could be taken away and crushed simply because the digital paper trail made it too expensive to keep on the road. This is the psychological cost of the quarter panel repair. It's the feeling of driving a marked car. Every time Marcus hears a tiny rattle or a bit of wind noise, he wonders if it's because of the repair. He knows that his vehicle's digital soul is permanently scarred. In the American consumer mindset of 2026, an accident is no longer a temporary setback. It is a permanent entry in a global database that follows the VIN number for the rest of its existence. You are paying for the repair, but you are also living with the consequences of that data being public knowledge. But what if the repair itself is flawed? What if the shop, despite its best intentions, missed something that only becomes apparent when the car is pushed to its limits? There is a final technical frontier we have to explore: the world of post-repair safety testing and the terrifying reality of the ghost in the machine. In the next part, we are going to look at why some repaired quarter panels can cause your vehicle's stability control to malfunction in an emergency. We will find out how a microscopic misalignment can turn your car's safety software against you. We are going to dive into the world of dynamic calibrations and why the most dangerous part of the repair is the first mile you drive after leaving the shop. The moment Chloe pulls her repaired sedan out of a high-end collision center in Phoenix in 2026, she believes the ordeal is over. The quarter panel is smooth, the paint is vibrant, and the bill has been settled by her insurance provider. However, as she merges onto the Arizona Loop 101, the vehicle begins to behave erratically. The steering wheel vibrates slightly when she passes a semi-truck, and the emergency braking system suddenly chirps a warning despite no obstacles being in her path. Chloe is experiencing the ghost in the machine, a phenomenon that has become a leading cause of post-repair litigation in the United States. This is the world of dynamic calibrations and the critical failure points of the first mile. To understand why Chloe's car is hallucinating, we have to look at the relationship between the structural repair of the quarter panel and the Advanced Driver Assistance Systems, or ADAS. In 2026, the rear quarter panel of an American vehicle is not just a cosmetic cover. It is a mounting platform for high-frequency radar sensors that operate as the car's peripheral vision. When a technician replaces a quarter panel, they are moving these sensors. If the new panel is off by even a fraction of a degree, less than the thickness of a credit card, the sensor's field of view is shifted by several feet at a distance of 50 yards. This is known as an angular misalignment, and it is the primary reason why a simple body repair now requires a sophisticated digital diagnostic phase. In the American repair market of 2026, there are two types of calibrations: static and dynamic. A static calibration happens inside the shop using specialized targets, lasers, and level floors. But the dynamic calibration is what Chloe is currently undergoing without even knowing it. For many modern American vehicles, the car's computer must be put into a learning mode. The technician, or in some cases the owner, must then drive the vehicle at a specific speed, usually between 35 and 65 miles per hour, on a road with clear lane markings and a specific amount of roadside clutter like signs and guardrails. The car's AI uses this drive to map its new physical orientation. If the road is too bumpy, or if the weather is too rainy, the calibration will fail. Historical trends show that nearly 15% of dynamic calibrations in 2026 are completed improperly, leading to safety systems that are either oversensitive or, more dangerously, completely unresponsive in an emergency. Consider a case study from a National Safety Research Institute, conducted in early 2026. They took 10 vehicles that had undergone professional quarter panel replacements and subjected them to emergency lane change tests. 3 of the 10 vehicles showed significant delays in their electronic stability control intervention. Why? Because the rear-mounted sensors in the repaired quarter panels were providing conflicting data to the central processor. The car's brain was receiving information from the front camera saying the car was straight, while the rear radars, slightly misaligned from the repair, were reporting a skid. This data conflict caused the computer to hesitate for 200 milliseconds. In a high-speed avoidance maneuver on a rainy U.S. highway, 200 milliseconds is the difference between a controlled stop and a multi-car pileup. The cost of this safety verification is a major component of the $7,000 estimate that shocks so many American drivers. A professional shop in 2026 must bill for the labor hours of a technician to perform the test drive, the specialized software access fees to the manufacturer's cloud, and the insurance liability coverage for that specific drive. If a shop tells you they fixed your quarter panel but didn't perform a post-repair scan and a dynamic calibration, they have handed you a loaded weapon. Potential outcomes of skipping this step include the automatic deactivation of your blind spot monitoring, or, in the worst-case scenario, the unintended activation of the automatic emergency braking while you are traveling at highway speeds. Imagine if Chloe's car was an electric vehicle with a composite quarter panel. In 2026, many EVs use specialized materials to reduce weight. These materials have different thermal expansion rates than the steel frame they are bonded to. If the shop used an unapproved adhesive or failed to follow the specific curing times in a climate-controlled booth, the quarter panel can actually shift slightly as the car reaches operating temperature during that first mile. This shift, while invisible to the human eye, is enough to throw the radar sensors out of alignment mid-drive. This is why high-end American shops now use thermal imaging cameras to verify the bond integrity before the car is ever released to the customer. The cost of this specialized equipment and the training to use it is baked into every labor hour you see on your invoice. Furthermore, we must address the issue of steering angle sensors and thrust alignment. When a quarter panel is hit with enough force to require replacement, the impact often travels through the unibody and affects the rear suspension mounting points. In 2026, a quality repair requires a four-wheel alignment that includes a reset of the steering angle sensor. If the rear wheels are pushed out of alignment by just 1/16 of an inch, the car will crab walk down the road. The ADAS cameras, which are looking straight ahead, will see that the car is moving at an angle relative to its heading. This triggers a lane departure warning that never turns off. The technician has to spend hours troubleshooting whether the problem is the metal, the suspension, or the software. In the United States, this diagnostic time is often billed at mechanical rates, which are significantly higher than body labor rates. Let's look at the legal landscape of 2026. American courts are seeing an increase in failure to calibrate lawsuits. When a repaired vehicle is involved in a second accident, forensic investigators now pull the black box data to see if the ADAS systems were functioning correctly. If the data shows that the sensors were out of alignment following a previous quarter panel repair, the shop that performed that repair can be held liable for millions of dollars in damages. To protect themselves, reputable shops now produce a calibration certificate for every job. This document proves that the sensors were tested and verified to factory specifications. This administrative overhead, the documentation, the data storage, and the third-party verification, is another $50 to $100 on your bill that didn't exist a decade ago. The complexity of the first mile is the ultimate proof that the quarter panel is no longer just a piece of the car. It is an integrated part of a life safety system. When you pay for that repair, you aren't just paying for the look of the car. You are paying for the certainty that when you slam on the brakes or swerve to miss a deer, the car's computer will react exactly the way the engineers intended. Chloe's vibrating steering wheel and chirping sensors are a warning that her repair is incomplete, a digital loose end that could have fatal consequences. But there is one final piece to this puzzle, a factor that is currently reshaping the entire American economy and the way we value our time. It is the reason why your car might sit in a shop for 45 days for a repair that only takes 30 hours of actual work. In the next part, we are going to expose the backlog crisis of 2026. We will look at the global logistics nightmare of specialized parts and the critical shortage of master technicians that is turning every minor dent into a multi-month waiting game. We are going to find out why the most expensive part of your quarter panel repair might actually be the rental car you're forced to drive for 2 months while your vehicle sits in a parking lot waiting for a single specialized rivet. The rental car bill sitting on Anthony's kitchen table in Dallas is a staggering $3,400. His car has been in the body shop for 58 days, yet the actual labor hours recorded on the repair order only total 32. In the United States in 2026, the delta between repair time and cycle time has reached a breaking point. Anthony is a victim of the backlog crisis, a perfect storm of global supply chain fragility and a domestic labor shortage that has turned the American collision industry into a bottlenecked system. When you ask why a quarter panel repair costs so much, you have to account for the secondary economic impact of the wait. You are not just paying for a technician's time. You are paying for the massive logistical overhead of a vehicle that is occupying valuable real estate while waiting for a single proprietary component to arrive from a warehouse 3,000 miles away. To understand the parts shortage of 2026, we have to look at the concept of just-in-time manufacturing. Historical trends show that car manufacturers have moved away from stocking massive regional warehouses with every possible trim piece and structural reinforcement. Instead, parts are often manufactured in small batches. If Anthony's vehicle requires a specific inner wheelhouse reinforcement that is unique to the 2025 model year, and that part is currently on backorder, the entire repair stops. In the past, a shop might have fabricated a small bracket or used a similar part from a slightly different year. Today, because of the strict metallurgical requirements and the precision needed for ADAS sensor mounting, substitution is impossible. If the part isn't exactly what the VIN calls for, the car stays on jack stands. For Anthony, this meant his truck sat untouched for 6 weeks waiting for a specific structural foam insert that costs only $45, but is essential for the vehicle's crash rating. This waiting period has a direct, quantifiable cost. In 2026, the average daily rental rate for a mid-sized SUV in a major U.S. city is $75. If your insurance policy has a 30-day rental cap, which most do, you are on the hook for every day beyond that. Anthony's 28 days of out-of-pocket rental costs essentially doubled the perceived price of his accident. Furthermore, the body shop must charge for storage. In high-demand markets like San Francisco or New York, shop space is at a premium. If a car is taking up a bay or a spot in a secured lot while waiting for parts, the shop may lose thousands of dollars in potential revenue from other repairs. This overhead is inevitably reflected in the higher hourly labor rates and administrative fees that have become standard across the United States. Let's look at a case study of a specialized aluminum rivet. In 2026, many high-end American vehicles require rivets that are coated in a specific anti-corrosive polymer. These rivets are often manufactured by only 1 or 2 suppliers globally. During a minor trade dispute or a shipping strike in early 2026, the supply of these rivets in North America plummeted. Shops across the country had thousands of vehicles that were structurally complete, but could not be finalized because they were missing $10 worth of fasteners. This is the reality of the modern American car. It is a global assembly of thousands of dependencies, and the quarter panel is the intersection where many of those dependencies meet. Beyond the parts, we must address the critical shortage of master technicians. In 2026, the United States is facing a deficit of over 100,000 skilled collision repair professionals. The older generation of body men, who understood how to handform steel, is retiring. The new generation must be as comfortable with a laptop as they are with a frame rack. Because the work is so specialized, the few technicians who are certified to work on structural aluminum or complex electric vehicle frames can command 6-figure salaries. Shops in the U.S. are in a bidding war for this talent. To retain a master technician who can properly replace a quarter panel on a 2026 Electron Volts, a shop owner has to provide top-tier benefits and high wages. These costs are passed directly to the consumer in the form of labor rates that have climbed from $50 an hour in 2016 to over $120 in many regions today. Imagine if Anthony's car was involved in a minor collision that also damaged the high-voltage battery housing located near the rear quarter. In 2026, many shops will not even touch a vehicle with a compromised battery until a specialized EV safety technician has cleared it. There are currently only a handful of these certified professionals in each state. The car might sit for 2 weeks just waiting for an inspection. This adds another layer of time and administrative cost. The shop must also invest in specialized fire suppression blankets and dedicated EV isolation zones to prevent a thermal runaway event while the car sits in the backlog. These safety protocols, while necessary, add hundreds of dollars to the facility's operational costs, which are then factored into every estimate. Furthermore, we have to consider the insurance adjustment delay. In 2026, many major American insurance carriers have moved toward AI-based photo estimating. While this is fast for the initial claim, it is notoriously inaccurate for structural damage. When the shop tears down Anthony's car and finds that the inner C-pillar is buckled, damage the AI couldn't see through the outer skin, they have to file a supplement. In the current labor market, insurance adjusters are just as overworked as technicians. It can take 5 to 10 business days for an adjuster to physically or virtually approve a supplement. During those 10 days, no work is done. No parts are ordered. The car just sits. This administrative friction is a hidden tax on the American driver's time and money. Data from the 2026 National Association of Body Shops indicates that the average length of a car repair in the US has increased by nearly 60% since 2021. This isn't because technicians are working slower. It's because the complexity of the handshake between the shop, the parts supplier, and the insurance company has become so cumbersome. When you pay $7,000 for a quarter panel, you are paying for the friction of a system that is struggling to keep up with the technology it is trying to fix. You are paying for the logistics of a globalized world that has forgotten how to be simple. Anthony's $3,000 rental bill is the ultimate symbol of this crisis. It represents a loss of productivity, a loss of convenience, and a massive transfer of wealth from the individual to the logistics and rental industries. In the United States, we have traded the simplicity of the past for the high-performance, high-safety reality of the present, but we haven't yet figured out how to make the infrastructure of repair as efficient as the factory that built the car. The quarter panel is simply the most visible symptom of a much deeper structural problem in the American economy. But there is one final overarching question that every driver in 2026 must face. After the parts arrive, the technician finishes the welds, the software is calibrated, and the car is finally back in your driveway. Is it actually the same car? In the final part of this masterclass, we are going to look at the ship of Theseus paradox in automotive repair. We will explore the long-term structural health of a repaired vehicle and the ultimate reality of car ownership in an era where nothing is ever truly fixed, only replaced. We are going to find out if the $7,000 you spent was a wise investment or just a temporary stay of execution for a machine that was never meant to be opened up. We will conclude with the one thing you must do before you ever sign a repair authorization in the year 2026. The ship of Theseus is a philosophical thought experiment that asks if an object that has had all of its components replaced remains fundamentally the same object. In the context of a 2026 American quarter panel repair, this is no longer a question for philosophers. It is a question for the structural engineers and the families sitting inside the car. When a technician cuts through the factory-baked pillars of a modern vehicle, removes the integrated rear section, and installs a new piece of metal using aftermarket rivets and shop-applied adhesives, is that car still the same 5-star safety-rated machine that rolled off the assembly line in Detroit or Fremont? The answer is the most sobering reason why these repairs cost $7,000 or more. In the United States today, you are not just paying for a repair. You are paying for the desperate attempt to maintain the original structural DNA of a vehicle that was designed to be disposable. To understand the long-term structural health of a repaired quarter panel, we have to look at the concept of fatigue life. Factory assembly involves robotic precision that applies uniform pressure and heat across thousands of spot welds. When a human technician replicates this in a shop in 2026, they are introducing variables. Even with the best equipment, a hand-applied rivet or a manual weld creates a different stress profile than a robot. Historical trends in automotive forensic analysis show that a repaired structural joint can have a different resonant frequency than the rest of the chassis. Over the next 50,000 miles of driving on pothole-ridden American roads, these microscopic differences in vibration can lead to stress fractures in the surrounding metal. Case studies from highway safety investigators have identified instances where a vehicle involved in a second, minor collision suffered a catastrophic structural failure because a previous quarter panel repair had created a weak point in the unibody frame. Consider a character named Robert in Houston. Robert's car was repaired after a sideswipe, and for 2 years it seemed perfect. However, in 2026, he began to notice a persistent creaking sound coming from the rear pillar every time he pulled into a driveway. This sound is the audible ghost of a failed bond. If the structural adhesive used during the quarter panel replacement has delaminate due to improper surface preparation or environmental stress, the metal panels are now rubbing against each other. This is not just an annoyance. It is a sign that the vehicle's secondary impact protection is compromised. In the event of a rollover, that creaking pillar may not provide the calculated resistance required to keep the roof from collapsing. This is why the labor hours for cleaning and prepping the metal are so high on your estimate. The shop is trying to prevent a structural failure that might not manifest for years. The data regarding modern vehicle lifespans in the United States suggests a troubling potential outcome. As the complexity of these repairs increases, the gap between a safe car and a totaled car is shrinking. In 2026, we are seeing the rise of the total loss threshold manipulation. Because insurance companies know that a structurally repaired car carries a higher long-term liability risk, they are more likely to push for a total loss payout, even when the physical damage appears manageable. This creates a cycle where the American consumer is forced into a new car loan every few years, even after minor accidents. The $7,000 repair is the price of trying to fight this cycle. You are paying to keep your vehicle out of the salvage yard, but you must accept that the car will never truly be factory fresh again. Let's look at the psychological weight of the repair authorization. In 2026, many American body shops are requiring customers to sign comprehensive liability waivers that extend to 30 or 40 pages. These documents state that while the shop has followed all manufacturer-specified procedures, they cannot guarantee the vehicle will perform identically to a factory new car in a future crash. This is a legal shield against the ship of Theseus paradox. When you sign that authorization, you are acknowledging that your vehicle is now a hybrid of factory engineering and field expedient restoration. This is the one thing you must do before you ever sign a repair authorization. You must demand a written copy of the OEM repair procedures for your specific VIN. If the shop cannot produce the digital manual from the manufacturer showing the exact cut lines and rivet locations for your car, you must walk away. In 2026, a shop that wings it is a shop that is gambling with your life. The financial reality of 2026 also includes the rise of certified inspections. In some U.S. jurisdictions, a vehicle that has undergone a structural quarter panel replacement must pass a secondary safety inspection before its registration can be fully renewed. These inspections involve ultrasound testing of the weld points and a verification of the ADAS calibration logs we discussed earlier. The cost of these inspections is often not covered by insurance and can add another $400 to the total cost of ownership. This is the final hidden fee in the long saga of the quarter panel. You are paying for the right to prove your car is still roadworthy. Imagine a scenario where Robert tries to sell his car in 2027. The buyer arrives with a handheld paint depth gauge and a mobile app that connects to the car's OBD2 port. The app flags the non-factory serial numbers on the blind spot sensors and the variations in the metal density around the C-pillar. The buyer walks away, not because the car looks bad, but because the digital footprint of the repair makes the vehicle an unknown variable. In the American market of the late 2020s, transparency is a double-edged sword. It protects the buyer from lemons, but it punishes the honest owner who did everything right during the repair process. The ultimate reality of car ownership in 2026 is that we have entered the era of the disposable high-tech machine. We have engineered vehicles that are so safe they can survive a 60-mile-per-hour impact, but they are so complex that they cannot survive the repair process without losing their soul. The quarter panel is the most dramatic example of this because it sits at the intersection of aesthetics, structure, and electronics. When that panel is dented, you aren't just looking at a bill for metal and paint. You are looking at the bill for the collapse of a trillion-dollar industry's attempt to keep the past alive. The historical trends indicate that as we move toward 2030, the cost of these repairs will only continue to climb. New materials like carbon fiber reinforced polymers and ultra-thin aluminum alloys are already being integrated into the next generation of American EVs. These materials cannot be repaired at all. They must be replaced as entire subassemblies. This will turn the $7,000 quarter panel into a $15,000 modular replacement. The era of the body shop craftsman is being replaced by the era of the modular technician, where the only tool that matters is the one that unplugs the old car and plugs in the new one. This brings us to the final conclusion of our masterclass. The reason a simple quarter panel repair costs so much in America is that there is no such thing as a simple repair anymore. Every dent is a digital event, every scratch is a chemical challenge, and every weld is a structural gamble. You are paying for the specialized knowledge, the global logistics, the digital calibrations, and the legal protections required to navigate a world where technology has outpaced our ability to fix it. Before you drive another mile in 2026, look at your car not as a piece of property, but as a complex, fragile ecosystem that requires a fortune to maintain once that ecosystem is breached. But the story doesn't end with the bill. There is a burgeoning movement in the United States that is attempting to disrupt this entire cycle. A group of engineers and legal experts are fighting to change the way cars are designed from the ground up to make them reparable once again. This movement, known as the Design for Longevity Initiative, is the only hope for the American driver's wallet. In our next deep dive, we are going to go inside the secret design labs where the cars of 2030 are being born. We will find out if the next vehicle you buy will be a modular masterpiece or another $7,000 trap waiting to happen. We will explore the revolutionary new materials that might actually make a dent a thing of the past. The battle for the future of your car is just beginning.